Here's my solution. I got rid of the docstring just so that the whole function would fit on the page. In general, I should bring that back. The docstring is an important part of the solution. But here's what I do. The heart of the function is just a call to shortest path search, start at the start state. We have a successor function and a goal function. The goal function just asks, is the goal number, that integer that we're trying to achieve, anywhere in the state? Is any one of the current levels of the glasses equal to the goal? And here's a successor function. And I'm going to build up this dictionary of results, which I call SUCC for successor. It's a dictionary of state action pairs. And I go through all the indices. That's equivalent to the glass numbers, 0, 1, 2, 3. I've invented this function called replace, and replace takes a tuple, an index into the tuple, and a value that we want that index to be. Now, why did I need that? Because tuples are immutable. So mostly this is saying replace state sub I with capacities of I, but I can't say that for a tuple, so I needed a function that's going to do it for me. So take that tuple with the state sub I replaced by the capacity. That's the same as the action of filling an I. Replace it with 0. That's the action of emptying. Now the action of pouring, which we have over here, is a little bit more complicated. So we have to go through all the glasses twice, pouring from I into J. We have to make sure that we're not pouring into yourself. And then the amount that we pour is the minimum of how much we have. We can't pour more than we have in the glass that we're pouring. And we also can't pour more than would fill up the glass that we're pouring into. So that's the amount we're going to transfer, and then we subtract that amount from the glass we're pouring from, and we add that amount from the glass we're pouring into, and we make that a pouring action. Then we just return the result. Then there's one little statement here that says, if you didn't specify the start state, make that be the tuple that contains all zeros and whose length is the same as the number of glasses we have. So that's the whole solution, except here's my replace function. So replace, in general, takes any sequence, but it's really most applicable for tuples that are immutable, makes that sequence into a list, mutates it because we are allowed to mutate lists, and then puts it back together again. And so what am I doing here? This might look a little bit unusual, but what I'm doing is I'm saying, tell me the type of the original sequence. A tuple could be a string, could be a list, and then call that, because types are functions. So in this case, it's going to be tuple, and then call tuple on this list S and make S back into a tuple. And I made it general like this so that it would also apply to lists and strings. And finally, here's the test cases, and if we run them, it turns out it works.